right, everyone, elasticity of demand. We're going to continue where we left off from last class period, but I want to start by doing some review problems for you. And I looked at the homework that you did last night, and it was a little bit, again, bimodal. Again, this is going to get a lot easier. It's just kind of practice, practice, practice. So it's like supply and demand in that you just got to get used to this content. So let's do some sample problems. And that means you need to have your calculators out. So everyone, please get your calculators out. And remember, you're going to need a calculator in this class for the next several lectures. So let's just have it handy, okay? So the most simplest kind of problem, well, the second most simplest kind of problem is where I just give you data. So let's say that the price of X increases from $8 to $10, and as a result, sales fall from 50 to 38 units per day. And we want to find the elasticity of demand. All right, so let's take a look at this problem because there's a number of things that I'm going to ask you to do with a problem like this. So finding elasticity of demand first. As I've suggested, always, please, please, please start with the equation in front of you. So percent change in quantity over percent change in price. So always write the equation first, and then you're going to plug in what you know. Because remember, there are some different kinds of problems where I might calculate the numerator and ask you to solve for the denominator, or vice versa. Give me 1 second. Roll sheet needs to go around. All right. There we go. Roll sheet's going around. Okay. So remember the new principle. New minus old over old multiplied by 100%. So I'm going to use that on the numerator and the denominator. So what's our new quantity, everyone? What's our new quantity? 38. 38 minus our old quantity of 50 over 50 multiplied by 100%. That's going to give me percent change in Q. Then I'm going to do the exact same thing on the denominator. So what's our new price? 10. So 10 minus our old price of 8 over our old price of 8 multiplied by 100%. All right, so far so good. Now, only when I have 100% on the top and the bottom, which some types of problems you won't, so you can't cancel it unless you have it on top and bottom. So I can clean this up a little bit. And then that gives me negative 12 over 50. And then 2 over 8. So one suggestion I have for you, if you have a little trouble with the total revenue part of this, is go ahead and convert to decimals at this point. 12 divided by 50 is negative 0.24. And then 2 over 8, we know what that is, right? It's wait, that can't be right. Is that right? Yeah, 0.25. Okay, everybody with me? I got this right? Check me and make sure I've made no errors. And then we're going to calculate it. So we get elasticity of 0.96. Remember, we take the absolute value, which is going to give us 0.96 as a positive number. All right. So the first thing I might ask you is this elastic or inelastic? Okay, so remember, elasticity less than 1 is inelastic. But do we agree on this particular example, it's very close to what? Very close to being what? Unitary elastic, right? So it's very close to being unitary elastic. Everyone agree with that? Because unitary elastic, remember, is elasticities that are equal to 1. So we have it's barely inelastic, just about unitary. All right. So the next thing I'm going to ask you is the impact on total revenues. The impact on total revenue. Again, you have to know the equation for revenue. So total revenue, revenue is P times Q. So I'm going to call it revenue. Sometimes I call it total revenue, same thing. So the impact on total revenue, we see that price goes up by how much? 25%, right? 0.25 is 25%. And quantity goes down by 24%, right? Do you agree with that? So what's happening here? Is revenues going up? Or are they going down? So in this example, revenue's going up, but is it going up by very much? Is it going up by very much, guys? Just barely, right? So revenues are going up, but just barely. Because the increase in what we make from price going up is just about completely offset by quantity falling. Everybody with me? So is this going to be a price change that generates a lot of revenue, folks? No, it's definitely not. So if your boss asked you, hey, we're thinking about raising our price from 8 to 10, and you know that that's going to result in quantity falling from 50 to 38, you might say, well, this is not going to generate the kind of revenue you're looking for because of the elasticity of our consumers being inelastic and almost unitary. All right, everyone understand that example? Okay, let's do another one. There are some examples where I might ask you to work backwards. What if there's a study, and that study reveals that the elasticity demand for good Y is 1.9. So a study reveals that the elasticity demand for good Y is 1.9. And your firm wants to decrease price of Y from, let's say, $6 to $5. And we want to know what is the impact on quantity. Okay. So a study reveals that the elasticity demand for good Y is 1.9. Your firm wants to reduce its price from 6 to 5, and we want to know the impact on quantity. All right. Now, guys, before even calculating anything, what do I know the law of demand is telling me about quantity? If I'm lowering price, then quantity does what? Quantity does what, everybody? Yeah. So remember, the law of demand tells us that quantity will go up, but we want to know how much. All right. So again, I would suggest that you start by writing out the equation. So elasticity demand is percent change in quantity over percent change in price. You have to work backwards on this problem. So we need to plug in what we know. So I can plug in for elasticity, 1.9. But what do I have to remember to do here? What do I have to remember to do? Is elasticity a positive relationship between P and Q, or is it a negative relationship between P and Q? It's a negative relationship, right? So if I just plug in 1.9, think about the implication, guys. If I plug in 1.9 here, that says if one goes up, the other goes up, or if one goes down, the other goes down. We know that's not the case. They move in opposite directions. So what else do I need to plug in? I need to remove the absolute value, and plug that negative back in, right? Does that make sense to everyone that I have to plug the negative back in? Because this is a negative relationship, right? Elasticity demand is a negative number, but we take the absolute value and express as positive. All right. The other thing that we can plug in is that we can calculate percent change in price. So I'm going to use that new equation to get new minus old over old multiplied by 100%. So what is my new price, everybody? 5. So 5 is my new price. Minus 6, my old price, over 6, my old price, multiplied by 100%. Guys, can I drop that 100%? Can I cancel it with anything? No, I can't, because there's nothing to cancel it with, right? I can only cancel if it's in the top and the bottom. So everyone take a second and calculate percent change in price. So I want to see everyone doing that. Calculate percent change in price. And then see what you get. So guys, everyone should be calculating this, not just sitting there. So what do we get? What do we get, guys? Is it positive or is it negative? Negative. What's the amount? What's the percent? 16.7. Good. So this is negative 16.7%. Guys, when I ask you to get out your calculators and calculate stuff, that doesn't mean sit there. Okay. So now we can clean this up, right? We've got negative 1.9 equals, I'm solving for a percent change in quantity, and on the bottom I've got negative 16.7%. So how do I solve this math problem? It's a cross multiplication, right? So to calculate percent change in quantity, I have to cross multiply. So I have negative 1.9 multiplied by negative 16.7%. All right, so everyone take a second and solve for the answer. So what do I get? What do I get, guys? What's the answer? 31.7%. So what have we just learned? If we change our price from 6 to 5, given that consumers have an elasticity of 1.9, then percent change in quantity is going to be 31.7%. Can I go back and check my work and make sure that I've not done anything stupid? Yeah. Negative 1.9 equals 31.7%, and I calculated the denominator is 16.7%. Does it look like the math works out? Yeah. Now, guys, let me show you one thing. What would have happened if I had forgotten my negative sign? What if I had forgotten to remove that negative sign? What if I had forgotten to put that negative sign in? So I'm starting with 1.9 instead of negative 1.9. Then this negative sign wouldn't be there. Everyone agree? And then this negative sign wouldn't be there, which would mean what about quantity? It would be negative. You would have told me that we lowered price and quantity fell. Would that make any sense? I lower price and quantity fell? Violates the law of demand, right? So it's kind of a small error to forget to put that negative sign back in, but by forgetting, you now, one, have the wrong answer, and two, you're violating the law of demand. So it's a minor error that leads to a very wrong conclusion. Everybody with me there? All right. So let's answer the question then. We've started to kind of get a sense of this. So let's answer the question, when can we raise our price and increase revenues? When can we raise our price and increase revenues? So let's think about this. From a business standpoint, when can we raise our price and make more money from it, guys? When can we raise our price? All right, so let's think about this for a second, guys. We're raising our price. What kind of consumers do we want to have? Do we want consumers that walk in and go, oh my gosh, the price has gone up. I'm not buying this anymore, or I'm going to cut way back. Do I want those kind of consumers? Or do I want the kind of consumers that walk in and say, oh, price has gone up, but I still really like this. I'm still probably going to buy about the same amount. Which kind of consumer do I want? The first or the second? Oh my gosh, I'm not buying this because price has gone up, or you know what, I still really like this. I'm still going to pay for it. You want the second kind of consumer, right? The second kind of consumer walks in and says, oh, price has gone up. Maybe I cut back just a little bit, but I'm not going to cut back very much. What kind of behavior am I describing when I say, nah, you know, price has gone up, but I'm not going to respond that much? What kind of consumer am I? Am I an elastic consumer or an inelastic consumer? An inelastic consumer, right? So when can we raise our prices and increase our revenues? When our consumers are inelastic. Remember why? Because they're not that price sensitive. They're not that price sensitive. You don't want the people that are very price sensitive because they're going to be like, oh, I'm not buying this. Let's look at it mathematically. We know that people who are inelastic have an elasticity less than 1, right? Elasticity less than 1. And that tells us that percent change in quantity over percent change in price is less than 1. So guys, what do we know if that equation, that expression is less than 1? What does that tell us about the numerator versus the denominator? Which has to be bigger, the numerator or the denominator? If it's less than 1, then which one has to be bigger? The denominator, right? So that tells us that the numerator has to be less than the denominator, right? So the denominator has to be bigger. So the numerator is less than the denominator. And if that's the case, then guys, the percent change in quantity has to be less than the percent change in price. Guys, put your phones away. So what this is suggesting then is whatever the price change is, you're going to have a smaller quantity change. So, for example, if you increase your price by 5%, your quantity is going to fall by less than 5%. You with me here? So, if we're looking at our revenues, and revenue is P times Q, then I can logic the same thing. If we increase by 5%, we're going to get something less than 5%. So in this case, guys, what has happened to revenues? Revenues have gone up. Everyone agree with that? So revenues have gone up. So when can we raise our price and make greater revenue? Only when we have consumers that are inelastic, right? We don't want them to cut back. So let's think about some examples. What about gasoline? What kind of demand do you think that gasoline has? What kind of demand do you think gasoline has? Do you think it's elastic or inelastic? What do you think, guys? Gasoline? Probably going to have a relatively inelastic demand. some gas has a relatively inelastic demand. Okay, I need it. What's another reason? We use it every day. What's another reason? Is there anything I can use? I'm sorry. Okay, prices change weekly. I'm not sure that it can even change daily. I'm not sure that affects my elasticity though. So I want to know what makes you inelastic. You need it. You need to get to work. You need to get to school. Is there anything else I can use? What were you going to say? Yeah, so what would I say? There's no substitutes. Exactly, no substitutes, right? So I need it, and there's nothing I can really use instead other than like riding a bike, walking. Okay? So if price of gas goes up, are we cutting back very much? No. Probably not. So might it make sense that we tax gasoline? Think about it. We tax gasoline. Are people going to cut back a whole lot? No. So we tax gasoline because it's a good place to tax. People don't cut back much. So we can raise the price of gasoline through a tax, knowing that we're still going to make some tax revenue. Guys, put your phones down. Take notes. All right, everybody with me? Does that make sense? So we tax because we know gasoline is an inelastic good, and that makes sense. What if gas was a very elastic good? What if we go to the pump and we see a tax and we're like, I'm not buying that? What happens? Do we make tax revenue? No. What if we tried to tax bologna instead? What would people do? So somebody says, you know what, let's stop taxing gas, let's tax bologna. What are people going to do? They're going to go to the store and they're going to say, oh my gosh, bologna's more expensive. What are they going to do? They're going to buy ham or roast beef or turkey, right? So what does that tell you about bologna? Is demand inelastic? No, it's probably what? More elastic, right? It's more elastic. So do you see why this kind of stuff matters? When I think about taxing, when I think about raising price, I have to know how people are going to respond. All right. So everyone have this in your notes? Okay, great. So now let's ask the same question. When can we decrease price and make greater revenues? When can we decrease price and make greater revenues? When can we decrease price and make greater revenues? All right. So let's think about this scenario for a second. When can we decrease price and make greater revenues? So you're a firm and you've put your product on sale. Campbell's soup. You're having a promotion. Campbell's soup is on sale. Do you want people to walk in and go, Campbell's soup? Or do you want them to go, Campbell's soup is on sale. Let's stock up. Let's have grilled cheese and tomato soup tonight. Which kind of consumer do you want? It's a sale. Doesn't really affect me. Or, oh my gosh, it's on sale. Let's stock up. You want the what? First kind of consumer or the second kind of consumer? Yeah, the second kind of consumer. You want people who respond to the sale, right? So we're decreasing our price. So we're putting our stuff on sale. So obviously, we want people to respond to the sale. So by responding to the sale, oh my gosh, Campbell's soup is on sale. Let's stock up. So if they're responding to the sale, then they are more price sensitive, right? Maybe they're going to stock up. So what kind of consumers are we describing here, folks? What kind of consumers are we describing? We're describing elastic consumers. Now, let's again look at the equation and the math so that we can see why this is the case. So, start with your equation. So, elasticity of demand. And if it's elastic, we know it's what? Greater than 1, right? Greater than 1? So we're looking at elasticity of demand greater than 1, right? Elasticity of demand greater than 1. So guys, if that equation is greater than 1, then what does that tell us about the numerator versus the denominator? The numerator has to be what? Greater than the denominator. Everyone agree with that statement? For that equation to be greater than 1, the numerator has to be greater than the denominator, right? Which tells us that the percent change in quantity is going to be greater than whatever the percent change in price is. So, if we decrease price by 5%, then what do we know happens to quantity? Quantity increases by what? By more than 5%, right? So do you see what's happening? I'm losing money from price because I put my good on sale, but what's happening to quantity? It's going in enough where I more than make it up, right? I more than make it up. So if we're looking at revenue, where revenue equals P times Q, if we lower our price by 5%, lower our price by 5%, quantity goes up by more than 5%. And of course, that means that revenues are going up here. So that's how we know that if we want to lower our price and ensure that our sale is successful and we want our sale to generate more revenues, we have to have consumers that are elastic. So guys, what happens if I lower my price and it turns out my consumers are inelastic? What happens? I lower my price and my consumers are inelastic. What happens to my revenues? They go down. I've lowered my price hoping people are going to buy a lot more, and people don't buy a lot more. So I've lost money from price being lower, and I'm not making it up in quantity because my consumers are inelastic. And now I'm in trouble with my boss. Okay? All right. So you need to be able to connect all of these dots, right? You need to be able to kind of figure out when does it make sense to lower price? When does it make sense to raise price? So you had some problems last night that said basically things like, if you increase your price and observe that your revenues are going down, then you know elasticity of demand for your product is blank. Everybody take a second and answer that question. you increase your price, and you observe that your revenues fall, then you know elasticity of demand for your product was what? What's the answer, guys? It's either elastic or inelastic. Elastic, right? So you raised your price, hoping people were not price sensitive, but it turns out they are price sensitive, and they cut back enough, your revenues fall. Everybody with me? All right. Easy stuff. So one more. If you lower your price and observe that revenues fall, then you know the elasticity of demand for your product is blank. You lower the price of your product and you see that revenues go down, then you know elasticity of demand for your product is what? Inelastic, right? You lowered your price hoping people say, ooh, let's buy more. Let's stock up. Let's have more soup this week. And that didn't happen. So you lost revenues because your consumers weren't responding to the sale. Not responding to the sale, not price sensitive, inelastic. Everybody with me? All right. Getting the hang of it? Okay. So the last thing that we're going to talk about today is determinants of elasticity. Determinants of elasticity. Determinants of elasticity. And what we mean by determinants of elasticity is what makes us more or less elastic. So what makes us more or less elastic, or more inelastic or more elastic? So what makes us more or less elastic in our behavior? What are the things that influence how elastic or how inelastic we are? So the first thing we've already hinted at. The first thing we've already hinted at. So remind me, why is gas? Well, what was one of the reasons that gas is inelastic? Because we don't have choices, right? So the first thing that affects our elasticity is the availability of substitutes. The availability of substitutes. So this is pretty intuitive. If there are more substitutions, oops, I should say substitutes, my bad. If there are more substitutes, more opportunities for substitution, then how are you going to behave, guys? Price goes up, but you've got a lot of other options. So are you going to be price sensitive or not that price sensitive? Yeah, I'm going to be more price sensitive, right? And more price sensitive means what? More elastic or more inelastic? I'm going to be more what? Elastic. More elastic. Good. More elastic. So if there are more substitutes available, then I'm going to be more price sensitive, which means I'm more elastic. But if there are fewer substitutes, then I'm going to have to be less price sensitive. So if there are fewer substitutes, I'm less price sensitive. If I'm less price sensitive, then I'm more what? Inelastic. More inelastic. Or another way I could say it would be less elastic, right? So those mean the same. All right. So that's pretty easy. So let's think about an example. What if we were talking about the demand for beer as a category versus the demand for Budweiser beer? Demand for beer versus the demand for Budweiser beer. And I want to know which has the more elastic demand. Beer in general or Budweiser beer? So everyone take a second and look at that question. So which do you think has the more elastic demand? How many of you say beer? How many of you say Budweiser beer? How many have no idea? Well, let's think about the substitutes. What are the substitutes for beer? Beer no longer exists, or we price it out of the market. Okay, liquor. What else? Wine. What else? What was that? Vodka. Vodka's liquor. So liquor, wine. What was that? Champagne. Wine coolers. Mint juleps, right? So frat party's not going to have a keg. They're going to invite you over for mint juleps. Well, I think it works, right? My kids are both frat boys. I can see that. All right. So we don't have a lot of substitutes for beer, but we have some. What are the substitutes for Budweiser beer? Ah, so Bud Light. What are the other close substitutes? Miller. What else? Michelob. Keystone. Right? Any other mediocre beer that we can come up with, right? But guys, is liquor also a substitute? Sure. And wine and champagne and mint juleps and all those other things. So where is there a greater opportunity to substitute? Budweiser. So let's say that we increase the cost of a six-pack of all beer by $2. Are there going to be some people who stop drinking beer? Yeah, but not that many, right? If we increase the price of a six-pack of beer by $2, my guess is a lot of people still drink beer. But what if we increase the price of Budweiser only by $2? What happens if we increase the price of Budweiser beer only by $2? Then what happens? Is anyone buying Budweiser? Probably not, because if you add $2 to a six-pack, you can buy just about any other beer, except for the most premium beers. So where are we going to see a bigger response? In the demand for beer or the demand for Budweiser? Where are we going to see the bigger response, people? In the demand for Budweiser, right? Good. So we would say that the demand is more elastic. What's the reason? There are lots of close substitutes available. So ability to substitute makes us more elastic. That makes sense, everyone, right? All right. So first determinant of elasticity, substitutes, ability to substitute. All right, second. The second thing that determines elasticity is the good a luxury or is it a necessity? Luxury or necessity? Now we talked about gas in relation to this. What did we say gas is? Is it a luxury for us or is it a necessity? Yeah, it's probably a necessity given that we don't have much mass transit here. There's not really a way to get places other ways. So what do you think is going to be the case? If something is a necessity, is it going to make you more elastic or more inelastic? It's going to make you more inelastic, right? Because you need it. But if something is a luxury, maybe it's my latte at Starbucks, I don't have to have that latte. When prices change for my latte, I might decide, you know what, this is something I can give up. So for luxuries, I'm going to behave how? More what? I'm going to be more elastic. Good. More elastic. And that makes sense. So things that are necessities are things that we are going to be less price responsive. Good. Number three. Number three is the size of the good as a proportion of your budget. The size of the good as a proportion of your budget. Size of the good as a proportion of your budget. So let's keep it simple. Let's say that something takes up a very small percent of my budget versus something takes up a very large portion of my budget. So let's look at those two situations. Something takes up a very small percent versus something that takes up a very large percent. Now guys, if price went up by 15%, which one impacts me more? Price goes up by 15%. So price goes up by 15%. Which one impacts me more? So price of whatever this is we're talking about goes up by 15%. Maybe my rent versus my latte. Where am I more affected? If it takes up a large portion, right? So I'm going to be more affected by a price change. And if something takes up a very small percent, I'm going to be less affected by a price change. So guys, where am I going to be more inelastic? Where am I going to be more inelastic, less responsive? When it takes up what? A smaller or larger? Smaller, good. So I'm going to be more inelastic here because it takes up a very small percent of my budget. But if something takes up a large portion of my budget, I'm going to be more what? More elastic. All right. So what's the punchline here? The larger the percent of your budget, the more what? The more elastic or more inelastic you are? Everybody, the more elastic or inelastic you are? The more elastic you behave. So last one, so that's 1, 2, and 3. We have one more determinant of elasticity. Number 4 is the time frame you have to react. The time frame you have to react. So good story to illustrate here. Took a group to Slovakia. We're in Poland, in the mountains. It's snowy, and one of my students didn't listen to the instructions about wearing pants. He's in shorts. I don't catch it, but he's in shorts. And we're about to hike up a snowy mountain. It is freezing. So he walks into a ski shop and buys the only thing he can find, which was the most ridiculous pair of fuzzy brown women's ski pants, and paid a lot of money for them because he didn't have much time to respond. Same thing happened to me. I go somewhere to make a big presentation about my research. I show up, my luggage doesn't, and I've got 1 hour at the mall to get clothing for the next day so that I'm professionally dressed. For both of us, a guy who needs warm clothes for the hike up the mountains, me needing to 1 hour get clothes for a presentation, how are we behaving? Are we more elastic or more inelastic? More inelastic. So the less time you have to react or plan, do we agree that we're going to be more inelastic, right? Just give me a suit. I don't care what the price is. I have to look professional by morning. Find me something that will fit me and I will pay for it. But if you have more time, so the more time you have to react or plan, then we can shop around. No, this isn't the right suit for me. I don't like the price. I'm going to be a little more budget conscious. I'm going to be more elastic. Okay? All right. So guys, we only have one more small topic to cover on Monday for elasticity, and then we will be done with this particular topic. So remember to read your announcements so you know what is due for homework.